So my recording was cut up before I complete this, so let's continue. So FDA generally recommends avoiding color coding in most instances. That's the basic rule. And color coding is reserved for special circumstances only. And after human factors testing and feedback on the prototype forms, all end user is received and evaluated by the FDA prior to use. So under special circumstances, color coding should be used. That's what it means. Only a few applications of color codings are appropriate. For example, caps for ophthalmic products to distinguish therapeutic classes. So what it means is ophthalmic products, eye care products, to distinguish them from other therapeutic classes. Okay, so let's see what the examples here. Okay, so if you look at these bottles, do you think you can distinguish which one is which, right? So look at it. They are manufactured by the same company and the same kind of colors. So it's very hard to distinguish which one is which. It's a bad example, right? So they are different drugs. They are using almost identical, I guess, secondary container, primary container. This is just bad example. Okay, and then look at these as well. Okay, so they look the same, although they are different antibiotics. Ampicillin versus amoxicillin, they're different. Okay, so pretty bad. So if you look at these colors, so anti-infective drugs are normally tan color. Anti-inflammatory steroid kind of drugs are kind of pink color. And then what is that? Mydriatic and the cycloplasmic drugs are red. And so on and on. Beta blockers, okay, blood pressure drugs are dark blue. Adrenergic agonistic, that kind of purple. Carbonic and hydrase inhibitors are yellow. So those are kind of recommended color coding. Okay, so you should not have these kind of labeling mistakes for sure. So, and then clear container labels. Text that is raised or recessed on clear, transparent, or translucent containers, is generally legible. Okay, so if you can feel it with the hand, individually overwrap the product so that a legible label is applied to the overwrap, and the product should be retained in overwrap until it is administered. Okay, that's fine. Transferable labels. Once an injectable drug is withdrawn from the commercial vial into a syringe for administration, the syringe no longer provides crucial information to the end user. Okay, so then how can you label it? So when possible, use a transferable or peel-up label that can be applied to a syringe. Okay, if you wanna hold on the syringe for a while, since the syringe doesn't have any label, that's what it means. You can maybe use a transferable label from maybe its original drug container and put that on the syringe. Okay, so that's to minimize the use of unlabeled syringe. Okay. So that's the labeling principle. So FDA has a lot to say about how to label, what to label on your drug product. Okay, and then finally packaging. Okay, so a container closure system refers to the sum of packaging components that together contains the and protect the dosage form. Okay, this includes the primary packaging components and secondary packaging components if the latter are intended to avoid additional protection. Intends to provide additional protection to the drug product. So packaging system is equivalent to a container closure system. So if you look at these, these are all container system. So a primary packaging content means, well, what's the difference between primary and secondary? The difference is primary packaging container component, they can make direct contact. So it means packaging component that is or may be in direct contact with the dosage form, meaning making a direct contact with the drug form, that is considered the primary packaging. Okay, so like the vials, syringes, and those make direct contact. Those are considered as the primary packaging component. Okay, then how it's different on the secondary packaging component. The secondary packaging material would not make direct contact, of course. that is not or will not be in direct contact with the dosage form, right? So it's going to be like what? Maybe blister pack outside of the primary container, or paper pack, or those kind of things, right? This includes any syringe accessories. Examples are plunger rod or safety devices, as well as that is traditionally considered a package, like the carton or bulk pack. Secondary packaging is an important part of keeping the product safe from damage or tampering, of course. Maybe we're talking about the plastic cap on your vials. Okay, vials and syringes are protected from breakage when encased in carton or blister pack or tray. Those are kind of secondary packaging materials. Okay. All right, syringe. Let's talk about it. So, a device for administering your parenteral drug product that consists of a rigid barrel fitted with the septum, of course. Okay. With a plunger at one end and a seal of needle at the other end. Okay, the needle assembly may be part of the device or separate. Okay, so the needle can be attached to it, or it could be separate. And the vials are these guys, container designed for use with parenteral drug product, of course, single dosage, or vial containing a single unit of a parenteral drug. Single use vial, where a single dosage of parenteral drug product can be removed, and then vial and its remaining content may be disposed. So they are single use. Okay. And then pharmacy bulk package vials. So we're talking about these guys. A container of a sterile preparation whose contents are intended for use in a pharmacy. Okay, at mixture programs. So pharmacy can mix up the drug and then sell them after that. So we call them maybe compounding. Okay, so used for filling of empty sterile syringe. Okay, after mixing up, then you're gonna fill up the individual syringes. So most be prominently labeled as not for direct fusion in the case. Okay, so understand those. And the piggyback vial, something like this, a piggyback vial. A vial that contains a parenteral preparation that can be attached directly to the tubing, okay, of a parenteral administration fluid. Okay. And the bag, of course, IV fluid bag, a sack of pouch, or pouch usually used for administration or storage of sterile parenteral drug, of course. And then ampoules, we talked about it, ampoule seal, filling operation, a container that is capable of being hermetically sealed and is intended to hold the sterile material. And the tray, these are the trays, secondary packaging material, a shallow flat receptacle with a raised edge of a rim, okay, used for carrying or holding or displaying finished product, a primary or marketplace package. Okay, so and a tray and its content may be encased in a shrinkage wrap, okay, with a cover or overwrap as part of a unit of use package kit. The blister pack. So these binary packs are called blister pack. A package that consists of molded plastic or laminated that has indentations. Be used as a blister, okay, when flipped into each dosage form is placed. Okay, understand those different packaging material. And the bottles, of course, a vessel with a narrow neck designed to accept the specific closure. Okay, applicator, dispenser, a dropper, glass, plastic, pump, and spray, all those things can go here. The dewar, these guys, a container usually made of glass or metal that has at least 2 walls with the space between. Okay, so it provides the insulation. That's what it is. Each wall evacuates so as to prevent the transfer of heat. Okay, the inside of the container often has a coating like a silvering on the side of the to reduce the heat transfer. Okay, and is used especially for storing liquefied gases or for experiment at low temperature. Okay, those are doors. And the packets, of course, an envelope into which only one dose of a drug product, usually in the form of granule or powder, has been directly placed. Those are the packets. Okay, and then what else? Secondary packaging components identify the FDA as serving one or more of the following functions. They should provide protection from excessive transmission of moisture or solvents into or out of the packaging system. Okay, and provides protection from excess transmission of reactive gases like oxygen, inert gas-based filler gas, or other organic vapor into or out of the packaging system. They also provide light protection and provides protection for packaging system that is flexible or need extra protection from rough handling, and provides additional measure of microbial protection, contamination protection. Special packaging is defined as packaging that is designed or constructed to be specifically difficult for children under 5 of age to open. So a lot of drugs have these caps, special caps that you have to push in to open, right? So that's for, that's kind of child-proof. So young babies, they should not be able to easily open and do something dangerous, right? So those are special packaging. Okay. So understand that. And then another thing, tamper-evident packaging. Tamper-evident packaging, okay. So it has an indicator or barrier to entry, which if breached or missing, can reasonably be expected to provide visual or audible evidence to consumer that tampering has occurred. Okay. So for example, your vial may have the plastic cap. Okay, so it's only after you remove the plastic cap then you can use this injectable vial by poking your syringe into it. So if that plastic cap is gone, that means there was a tampering probably happened, so you should not use this drug. Okay, so that plastic cap should be always on there. Okay, so currently FDA has strict mandates, okay, regarding tamper-evident packaging, especially over-the-counter drugs, because there had been, incident in the history, okay, like Tylenol tampering and things like that. So pharmaceutical 21 CFR Part 11 211 subsection 132 says, however, parenteral manufacturers typically incorporate tamper-evident packaging as well. Vials use caps or seals to ensure or secure the rubber stopper in the container. These seals are usually kept with a plastic top. We're talking about that. Which when removed, cannot be repositioned. Once it's removed, you cannot put it back. That's what I meant. So then when syringes are packaged in blister pack or tray, these materials are designed such that it is immediately apparent if the blister or film has been breached. Okay, then you should not use that again. In some cases, labels can also be applied in such a way that it is evident whether or not the product, even just the label itself, has been tampered with it or not, just like that. Okay, so if you want to use it, you have to remove that label. Okay, and the packaging machines and operations, read about that. High-speed automated machines, things like that. Automated syringe blister. Okay, I will just have you read over this part. High-speed syringe assembly machine and blister packaging machine. Okay, and then tray pack thermoforming machine. Okay, I'm not an engineer. Okay, final assignment questions. Okay, what is the product SysPQ? Okay, what does it stand for? Okay, safety, identity. What does that say again? Strength. Okay, and purity and quality. Right. And what are the major classifications of product defects that could be identified during inspection? Those are critical, major, and minor. And what are the examples of those? You can talk about those. And what is the acceptable quality limit, AQL limit? And what happens if the defect rates identified by an inspection exceeds AQL? Okay, so AQL is the maximum defects you can have. Yeah, okay, and they should be identified and sorted out. And if you have more than higher than AQL limit, then you have to investigate what that is and where they're coming from, of course. How is a manual inspection normally performed? We talked about that, using a light booth, gently holding, certain position away from the light, and you gently